Hi guys, let's proceed. The next preset derivative that we can use is derivative of product. Basically, this formula, right, tells us on how to differentiate when we encounter with a situation of a product between two functions. As you can see here, right, we have two functions that being multiplied, right? So this is the formula. Looks rather complex, but it is actually not. If we just try to change a bit on how to write it, okay, so the derivative for product is actually u times v prime plus with b times with u prime. What does it mean here? They are the same. It's just that instead of doing writing down d over dx, I just put prime, so it will see a little bit simpler. Okay, the way to use it is also simple. Okay, basically when you have the product of two functions, you are going to define one as u and another one as v, right? So let's say this is u and this is v, and then the next thing to do is to differentiate each of them. So you're going to have u prime for u and v prime for v. After that, just substitute it in this arrangement, and you will have the derivative of product of these functions, right? So let's do an exercise. Let's look at the first question. You have the multiplication between these two functions. Okay, so let's apply the formula of dot product. Product. So we are going to define this as u and this as v, or you can do the other way around, doesn't matter. So we have u and v here, and as required by this formula, we'll need to define u prime and v prime. So we are doing that. So this become 12x squared and v become 7. After that, substitute everything into the formula. We have u v prime, so this times with v prime 7 plus with v, which is this, times with u prime 12x squared, and lastly multiply everything and rearrange it, right? Sum whichever numbers that you can, or subtract it, right? So this is the answer. This is the derivative of product for these functions, right? For the next question, we have another way of solving this one, but for this, up to this point, right, to solve it using product rule, you are going to expand this. So x squared plus 6 times with x squared plus 6, and you are going to do the same thing. Okay, however, as we go on later, you're going to see that we able to solve this using other methods, which is easier. No need for you to expand anything, right? So that's it for product rule. The next one is derivative of quotient. In other words, when you encounter with functions, right, that involve division, like this, a division between two functions, in order for us to differentiate, you are going to use this formula. Okay, this is the simpler version of it. V u prime minus u v prime over v squared. Alright, as you can see, we still involve u and v, and we still need to look for u prime and v prime. Basically, when you encounter with a question like this, you are going to need to do the same thing as product rule before, which is define u and v and find the derivative of u and v. After that, you are going to arrange it, you put it in this formula and solve it. Okay, so let's try to look at exercise. Okay, let's try to do this exercise. Okay, so for this one, let's define the u and v. Usually we just take u as for the numerator and the denominator from v usually. So let's find that. Okay, this is as u and this is as v. Next, let's find the u prime and v prime like this. Right, so 3 and 10x. After that, just input everything into the formula. So v u prime minus with u v prime over v squared. After you have input everything, just simplify it. Okay, simplify it to get this final answer. Okay, usually we don't really simplify it till the end. That is just sufficient. Usually we just leave the denominator like this. Okay, just leave it like this and try to simplify those numerator. Right, so this is the functions and this is the derivative of that function using quotient rule. So you can try to do the second one by your own. And now the next one is derivative of trigonometric functions. In the derivative of trigonometric functions, right, you can see a handful of formulas, right, that you will need to refer to. Right, for example, if there's sin x, when you conduct the derivative of sin x, it will become cos x, and sin kx become k cos kx. So there is several, as you can see here. Right, you can try to look at the you can look at YouTube and you'll see that there will be some videos that share to you on how to actually memorize this. There has a tips there, you can try to look at that. Okay, so the idea is to use all of the given derivatives of trigonometric functions, right, to solve the problem of trigonometry. So however, up to this point we have learned several methods of derivatives, right? So you might encounter with you might need to use a composite derivative, because as you can see here, this is a trigonometric functions together with a quotient rule. So you might need to use two things in solving one question. Okay, so let's try to look at exercise 4.6. Okay, so as you can see here, we have a product rule, derivative that need us to use product rule. However, we also have trigonometric function inside this function, this equation. So just go ahead and define u and v and find out u prime is 2x. As for v, you can try to refer the table just now. The derivative of cos x is negative sin x. Next, plug it in, right? You have u v prime plus v u prime, and just expand it and see whether it can be simplified further. In some of the trigonometric cases, you might need to deal with trigonometric identity and things where also require you to memorize things. That what makes trigonometry quite distance from us. However, what can I actually advise is search for YouTube. Just learn on how to easily memorize trigonometry, and later you can apply it in this in solving derivative of trigonometry. However, right, instead of, you know, let's say you don't really have enough you're really good in solving trigonometric functions, you know, and identity and everything, we still I still expect that you're able to do up until this point, right? Just do the derivative and do the product rule and try to simplify it or expand it. Okay, let's try to look at the next one, which is this. For this one, we have a quotient rule. So let's do the u and v, right? U times x, v is x, and for tan x, derivative of it is secant squared, and for x is 1. After that, substitute everything in the quotient rule, right? So v u prime minus u v prime over v squared. As you can see, there's nothing much to do. Just substitute and multiply whichever you can, and this is the answer. Okay, the next one is derivative of exponential and logarithmic function. Again, just like trigonometric, we have some properties, some formulas that you need to remember by heart. Okay, so there is not much. We have 5 rows here. Okay, so basically, if you look at the exponent, you'll see that if ex, right, when you conduct the derivative, it remains the same. If you have a constant, you will need to put the constant in front. And for this one, ax, the derivative of it is ax. A here stands for a constant. Right? The derivative is ax ln a, which is the value of a. And for ln x and ln kx, it will give you 1 over x as the derivative. Then you have properties of ln. Whenever ln have power, how to deal with it. If it is ln ab, the same as the summation of a and b. A over b, it is the same as a ln a minus ln b. Okay, so let's see. Let's do an exercise a bit. The first one, x ln x. Right, so if you look at it properly, you're going to see that we have x times with ln x, which is allow us to use product rule. So by product rule, we need to define x and v, and after that the u prime and u and v, and then we have u prime v prime. Okay, and after that, input it in the formula, right, and you have the answer here. Okay, so for the next one, we have x over exponent of x, power of x, which is quotient rule. So we have u and v here, then just input it in the quotient rule formula, and you get this. Alright, you can leave it like this, but it can still be simplified to, alright, you have ex over ex squared minus x ex over ex squared. So we can cancel out the e. That will give us 1 minus x over e to the power of x. Right? However, both of the answer is correct, whether you simplify it or not. Unless the question asks you to simplify it, then this is still considered correct. Okay? So that is some of the basic formula that we have in differentiation, and we're going to have several more composite derivative functions that we're going to learn after this. Thank you.